Well, hello once again, BC Calculus students. Let's get ready to take a look at how to score the 2015 free response. So some of you are still forgetting. The idea is that you should be watching this video after you have finished questions 1 through 3 here of the 2015 free response, but before you turn it in to me. What you really want to do is finish the 3, watch the video with your work in front of you, score your work according to the AP standard. Then after your work is scored, take a picture of your scored work and turn that into me. That's really the order that you should be doing it in. That's ideal. All right, so here's question number 1, classic rate in, rate out type of question here from 2015. And so let's take a look at how we're going to go about solving this and doing our answers. Notice that in this case, both of our rates are given to us as equations. Okay, so we have a rate out and we have a rate in. Both of them are given in equations. So let's go ahead. So first part here, part A says how many cubic feet of rainwater flow into the pipe during the 8-hour interval. This is just going to be a straight integration setup. We get the rate in function, which is the R function, and we integrate from 0 to 8 of that function, and that'll give us the total. Setting up, knowing that you need to integrate the R function, just having the correct integrand is all you have to do. You don't have to have the 0 and 8 and all in order to get the get one of the points. The second point is all included for having the 0 to 8 and getting that 76,570. Okay, part B is the amount of the water in the pipe increasing or decreasing at a time of 3 hours, and give a reason. So what we have to do is we have to compare the rate in and the rate out at that time. So if you compare the rate in, the R of 3, and you consider the D of 3, the rate out at that time, you get 1 point for simply understanding you have to compare those two. And when you simply compare the two and you find that the rate out is faster than the rate, is greater than the rate in, or if you want to think of it, when we take the difference between the rates, it's negative. Therefore, the amount must be decreasing since the rate that it's coming in is less than the rate that it is going out. You have to explain that with your reason and have that information there. That gets you the second point there for B. Part C were 3 points. So part C, we want to know at what time do we have the water at a minimum and justify. When we say justify, we know that we are going to have a fairly substantial explanation. Pretty much whenever they ask for a minimum, usually the best, when it's a closed interval, usually the best way to do it is to use the candidates test. That's where you simply check what the max or min is at each candidate. So that's either where you have a local max or a local min. In other words, where the rate is equal to 0, or at an end point. So the first thing, the fact that you know you have to look for where the rate is equal to 0, you get a point. So in other words, you're finding critical points. You find that those are essentially 2 critical points then at 0 and at the 3.271 658, and then you also must check the endpoint here of 8. So if you check all of those, what you find is the place where you have your minimum. Your smallest value is going to be the 27.964. Therefore, that occurs at this time of 3.272. So that will be your, in this work here, this checking of the candidates basically is your justification, that you checked all the places that were candidates, both endpoints and any critical points, any relative maxes or mins. Then finally for D, it says the pipe can hold 50 cubic feet of water before overflowing. And we know that for a time greater than 8, the water continues to flow into and out of the pipe at the given rates until eventually it will overflow. And wants us to write an equation, but don't bother to solve it, involving one that gives a time when it begins to overflow. So the time when it begins to overflow is going to be when that amount hits 50. So here's our basic equation here. So we've got our equation for 30, which is where it starts. We've got our 0 to W, and we have our rate minus our rate, our rate in minus our rate out. And when we get a time, when we get the upper limit there, where that hits 50, we know that we've got a point where it overflows. And so the integral is this 0 to W of the difference here. The total equation is knowing to set it equal to 50 and knowing to have the plus 30 out here. That gets you the other point. Okay, let's look at number 2. So score that out of 9, and we'll move on to number 2. So number 2, now, generally speaking, and this year, all bets are off because it's 2 questions. But generally speaking, I will say this, they do say it's going to emphasize BC material. So there will probably be one question that's either going to incorporate, I started to say it would incorporate vector, or but I have to go back and look and see. There's one bit that it won't incorporate. It will incorporate the series math, but not all parts of it. I believe it is the there won't be something on vector, polar, or normally question 2 is a calculator one involving vector, polar, or parametric. This year's I don't think we'll have that though. But you still should understand it because you're going to be expected to know it when you get into college. So let's take a look at it here. So first, we're given the following information here. We're given a formula for position. It's the vector equation there, and we're given a velocity vector. So for part A, it says find the x-coordinate of the position of the particle at that time of 2. Well, we have velocity. So to find the x-coordinate, we must find the x position. So we must take our starting position, 3, as our starting x, and then find the difference going between our 1 to 2 of our x component there of our velocity. So we integrate there. So if you get the integral, that's this part here, with limits, you get 1 point. If you remember to add 3, you get another point. And then if you actually know how to evaluate that correctly in your calculator and come up with a correct answer, you get your 3rd point. Okay, part B. Part B, this involves knowing how to take a derivative, to find the slope, which you know you have to take your dy dt over your dx dt. And since they give you the velocity equation to start with, then you don't have to differentiate those. You just use those. Those are the given values. And so doing that, if you get your slope right here, that gets you 1 point. If you substitute incorrectly and get this, that gets you your 2nd point. Pretty straightforward again. Speed. We know speed is going to be the square root of the sum of the squares of the position derivatives for x and for y. So we see that we already had those derivatives. We square both of those, take the square root. So if you get this equation right here, you get 1 point. If you correctly evaluate and get this, you get your 2nd point. And finally, for part D, 2 points. Your integral gets you 1 point. Okay, knowing you're integrated from 0 to 1 of that to calculate for distance. Basically, it's the integral of your speed. So you go ahead and do that. And then you get the correct answer. You get the other point. Score it out of 9. And let's move on to question 3. Okay, question 3, we've got velocity values in a table. I can almost guarantee you they're going to want us to estimate position using a Riemann sum somewhere in here. So let's see what we've got here. Looks like they're going to ask us to do that in part A. So we have to, oh, never mind, sorry. They want the derivative of v of, we want the derivative of v at 16. So we have to find the slope there So at 16, halfway between 12 and 20, change in y, 40, over change in x, 8. So if we have that 40, we have the setup. This is one where if they don't see a fraction, if you just jump and say 5, you're probably not going to get the point. They probably need to see some expression of a fraction that you set up, some difference. If you just say 5, even though you could do all that in your head, they're going to want to see that expression where they can see that difference of y over difference in x set up. Part B, we're 3 points. So 1 point for your right Riemann sum. This line right here gets you that point. This line does not. So if you skip this line and just go to this one, that would not give you the point. This line here gives you both the last 2 points. This line here gives you the sum and the approximation point. This line together with this line and this together with this line would get you the both points. But just this line will not get you any points. And just this line would get you approximation, but not the middle point of the Riemann sum. You need this line here. Okay, and then the explanation does get you a point because it does ask to explain that this integral from 0 to 40 of the absolute value of velocity is the total distance that she jogs from the time of 0 to the time of 40. So explaining that that means the total distance over that given time, 0 to 40. Then for C, if they understand, they must use b prime of t. So if they know that they're going to use that, they get a point. Even if they don't take the correct derivative, they still get a point. Just the fact that they know that they need that. So that gets them the point there. Then 1 point for the answer if they correctly take the derivative, plug in, and get 15. And then for part D, the integral, that's the limits and this expression inside there, that gets a 1 point. The antiderivative, that's this expression inside of brackets, gets you a 2nd point. If you put the wrong limits here, you would lose the integral point, but you could still get the antiderivative point. And of course, if you have the wrong limits, you're not going to get the answer point, but the answer point also relies on this 1/10 here. So this gets you the answer point right here, or you can say 350. But you can't have this and then do it incorrectly and still get your answer point. Okay, score that one out of 9, score the whole thing out of 27, and then go ahead and post that into your work for me to take a look at. All right, sounds good. If you have questions, we will be meeting on Zoom tomorrow at, I believe it is 1:30. So we'll see you then if you have questions.